Hello everyone, I am Someshi Shanapati, Assistant Professor of Civil Engineering at Vedant Institute of Technology. In case of soil mechanics, we have already discussed all the limits like plastic limit, liquid limit and shrinkage limit. So next we will come to Atterberg indices. So in case of Atterberg index, there are various more index. Those are like one is plasticity index, shrinkage index, flow index, toughness index, consistency and liquidity index. So we will discuss these indices one by one. Let's come to what is plasticity index. So plasticity is nothing but the range of consistency in which soil shows plasticity properties or behavior. Okay, as in that diagram, in our previous diagram that we have already seen here. So let's first visit that diagram once. Okay, we have already discussed these things in our previous classes. So here first go to plasticity index. So plasticity index is nothing but difference between liquid limit and plastic limit. Okay, so we can remember the difference between liquid limit and plastic limit is plasticity index. Likewise, shrinkage that is shrinkage index shrinkage limit, we will discuss that here. So in plasticity index, here plasticity index is nothing but plasticity index is denoted by IP and it is the difference of liquid limit and plastic limit. Okay, so plasticity index cannot be negative, right? Why? As the diagram was like that. Okay, so in case of here we have WL, WP and WS. Okay, we have yeah, we have three things. One is our liquid limit, plastic limit and shrinkage limit. As we know, water content is increasing. Okay, so while increasing of water content, there will be the most when the water content is at upper limit, that will be our liquid limit. So here we can just take one point as proof, okay, or highlight that point, that always liquid limit is more than plastic limit. So we can say liquid that the IP will never be negative, right? So if IP lies between 0, then we can say it is non-plastic in nature, or if IP is less than 7, then plasticity index, or it is, we term that as low plastic. If the values lies between 7 to 17, then that will be termed as medium plastic, and if more than 17, then that will be termed as high plastic. Okay, so we have understood plasticity index. In plasticity index, there is nothing, that it is the difference between liquid limit and plastic limit. So next come to what is shrinkage index. Shrinkage index is like that also. In this diagram, first we have WL, WP and WS. So the difference between WL and WP is IP, and the difference between plastic limit and shrinkage limit is nothing but our shrinkage index. Okay, so we term it as IS is equal to WP minus WS, where WP is plastic limit and WS is shrinkage limit. Okay, so further definition says that it represents the range of consistency in which soil will behave like a semi-solid material. Okay, so first thing, if water content is higher, soil will behave like liquid or it will start flow. Then soil will, if we just lower some water content, then the soil will behave like what? Plastic. And if we just lower some amount of moisture content, then soil will behave like semi-solid. Okay. So, this defines as the difference between plastic limit and shrinkage limit, as I have already told. Okay. So, IS is denoted by, shrinkage index is denoted by IS, and IS is equals to WP minus WS, right. Next comes to what is flow index. Flow index is the slope of flow curve is termed as flow index. Okay, and on who is represent what? The rate of loss of shear strength of soil with increase in water content. So the formula for flow index is IF is equal to W1 minus W2 log N1 minus log N2. So what are these things? Here, if we just draw one flow curve, so here there will be number of flows and this axis or y axis shows water content. Okay, we will understand later why this curve is like this and why we take these things. Okay, so when number of flows increases, there will be increase in water content, right. So the scale will be here. We just need to remember the formula, that is IF is equals to W1 minus W2. What are the W1 and W2? Here, this is 0. If we just increase, if we increase water content, here we will have W1, here W2, W3 like this. Okay. And in this scale, we will have N1, N2, N3 and so on. Okay. So, we will have the formula, that is IF is equals to W1 minus W2 upon log N1 minus log N2. So, we can also write IF as W1 minus W2 upon log of N1 by N2. Okay. So, here for flow index we have the formula as IF is equals to W1 minus W2 log N1 by N2. Okay. Next is toughness index, that will be represented as IT. It represents the shear strength of soil at its plastic limit. Okay. So, it is defined as the ratio of plasticity index to flow index. So, IT will be what? Plasticity index to flow index, that is IP upon IF. Okay. IT is your toughness index, IP is your plasticity index, and IF is nothing but the flow index. So, the value should be lies between 0 to 3. We can say the toughness index value, that is IT, should be always lies between 0 to 3. Okay. Next is our consistency index and liquidity index. Okay, these are very similar to each other. So, the formula, this index represent what? In situ behavior of soil. In situ is what? Like inside, when soil is present and there will be no change. That behavior is termed as in situ behavior of soil, and these indexes are represent the degree of firmness of soil. Degree of firmness means how much fine material are present in case of soil. Okay, so this is the formula of consistency index, and here is the formula of liquidity index. IC is what? Liquid limit minus W by IP. W is nothing but normal water content. Okay, you can write here normal water content. Okay, and IC is nothing but consistency index. Okay, and here IP is nothing but, as we have already said, that WL minus WP. So we have the formula here, that liquid limit minus natural water content upon liquid limit minus plastic limit, that is consistency index. So, and liquid limit is what? Liquidity index is natural water content minus WP upon IP, that is WL minus WP. Okay. Here we have the formula for consistency index and liquidity index. So from this we will have relation between IC, IL and IP. Okay. So here IC, IL and IP, we will have one relation from this, and in our next class if we have the values of liquid limit and plasticity, then we will put that and we will do some numericals to find out this consistency index or liquidity index and plasticity index. Okay. So in our next class we will solve a lots of numerical on the base of this. So to watch those videos you need to stay tuned here. Keep smiling and keep signing. Thank you.